So before we talk again, maybe at some point about graphing, I want to just talk a little bit more about converting from exponential to logarithmic form. Again, it's kind of like going from your native language, which may be English, and going to, and I just somehow picked Spanish, I don't know why, but to Spanish. And so I need to be able to go backwards and forwards from these two languages so that I can understand this thing called a logarithm. When I was a young person, it seemed so vague and so foreign to me. It took me a couple times of studying the concept of logarithms to really understand that a logarithm is an exponent. And a logarithm behaves like an exponent. As a matter of fact, I just want to share with you, at some point we're going to get into the thought that, remember how x to the second times x to the third equals x to the fifth? Because when the bases are alike, we learned that you could add the 2 plus 3 to simplify that expression. Well, because logarithms are exponents and they behave like exponents, we're going to learn that the sum of two logarithms can be thought of as a product, or the product of two logarithms can be broken out into the sum of two logarithms. So before we can do that, we've got to go from this statement to this statement. So would you please remember that the exponent is all alone in the logarithmic statement. Then you put your equal sign down. Then over here, your base was the letter A, so that's where the base goes in the logarithmic statement, and then this leftover letter goes at the end of the sentence. So if I'm asking you to find the values of this expression right here, I'm asking you to say 10 has to be raised to what power? Because remember, a logarithm is a power. 10 has to be raised to what power in order to get 1,000? So sometimes you can type these on your calculator, but I'd like you to kind of think through this and say, well, gee, 10's got to be cubed in order to get 1,000, because 10 times 10 times 10 is 1,000. So again, what power, I'm asking you, 2 has to be raised to what power in order to get the number 32? That's what I'm asking when I say what's the log of 32 where the base is 2. I'm asking you what's the exponent on the 2. Now you may know that it's a 5, that 2 to the 5th power is equal to 32. And you know, if not, how are you going to get that? Well, there's a couple of ways here, but the answer here is 5. There's a couple of ways. You know it's got to be 2 to some power, so you could take your calculator and go, well, 2 times 2 is 4. That's not it. And then you could hit times 2, and it would tell you that's 8. And then you could go times 2, and it would tell you that's 16. And then you could go times 2, and it would tell you that's 32. And you'd go 1, 2, 3, 4, 5 times. I multiplied 2's together to get the 32. Finally, there's another way to show you how to type this on your calculator, and I'm going to introduce now what's called the change of base theorem with this problem. On your calculator, if you want to find the log of 32 where the base is 2, would you please type now on your calculator log, and just hit the log key that's on the leftmost column, a little bit towards the bottom of your calculator. Would you go ahead and open parentheses and type a 32, and then you got to close parentheses, and then I want you to hit the divide by symbol on your calculator, and then I want you to hit the log key again, and would you have it open parentheses? If it does not, and then would you put the 2 in, and then would you have it close parentheses, and then would you hit enter? Do you see this log 32 where the base is 2? There's this thing called the change of base theorem that lets you take the log of 32 divided by the log of 2, since your base is 2. And you can use whatever base you want to do this, but your calculator is designed such that it uses base 10. That's the world we live in. We have 10 fingers and 10 toes, and that's where we came up with the base 10 world, seriously. And so that log key on your calculator is understood to have a base of 10 here and a base of 10 here. So when you type the log of 32 divided by the log of 2, it knows that you want to know what power should you raise 2 to in order to get 32. So I hope you get an answer of 5. So let's say you wanted to type this one on your calculator. I want you to know that you just type the log of 81 divided by the log of 3, and I'd like you to start getting used to that. And you should get an answer of 4 for that. And that's because 3 has got to be raised to the 4th power in order to get 81, because 3 times 3 is 9, and another 3 times 3 is 9, and 9 times 9 is 81. So the log of 81, where the base is 3, the answer for that problem is 4, because 3 gets raised to the 4th power in order to give us 81. So let's look at this question number 2. 4 gets raised to what power in order to get 1? And as a matter of fact, look at question number 3. 13 gets raised to what power in order to get 1? How can you take different bases? 4 and raise it to the 0 power and get the number 1, and 13 and raise it to some power and get the number 1 also, unless you raise that to a power of 0. Remember that anything to the 0 power is equal to 1. So we've just learned that the log of 1 is always equal to 0. Let's write that down. That's a theorem. The log of 1 is always equal to 0. It does not matter what its base is, because any base, anything raised to the 0 power, is always 1. You know, isn't that funny? That's an exponent rule that you never thought would come back to haunt you. Here's another one that's going to cause us to think of another theorem. The log of 9 where the base is 9. Gosh, so what power do you have to raise 9 to in order to get 9? That's what this is asking. 9 gets raised to what power? Well, that's got to be a 1. This has got to be a 1 right here, because 9 to the 1st power will give you 9. So whether it's log of 9 where the base is 9, which is, and I'm going to go ahead and fill these neatly in, which is equal to 1, or the log of 17 where the base is 17, that'll be equal to 1. This is theorem number 2. Here's theorem number 1. Theorem number 2 is the log of a base of a number, where the base is the same, is always equal to 1, because this has to be raised to the 1st power in order to get that. All right, this one would be hard to do without a calculator. So the easiest way to do that is to type the log of 64 divided by the log of 16. And that should give you 1.5, I believe, is what that gives you. What I do with this one is I say to myself, 16 has got to be raised to what power in order to get 64? And I'm kind of going, what if I took the square root of 16? The square root of 16 would be 4. What would I have to do to 4 to get 64? I'd have to cube that. Well, I happen to know these raising powers to powers where I have fractional exponents. And I happen to know that 16 to the 3 over 2 power means 16 to the 3 over 2 power means 16 to the 1/2 power cubed. And remember, 16 to the 1/2 power means the square root of 16 cubed, and the square root of 16 is 4, and 4 cubed is 64. So I kind of knew the answer to this problem was 3/2 or 1.5, because in my mind I could envision taking the square root of 16, getting 4 and cubing it and getting 64. This topic was chapter 11, and I may have had you watch my chapter 11 videos to get you ready for these thoughts. Not that we're going to use them that much. Finally, this last question is really a critical thinking problem. I kind of like to do this. I kind of like to say to myself, what's the answer to this? 6 to the log of 13 where the base is 6 power is question mark. Why? And then what I do is I take this, oops, I meant to do this in a highlighter. I take that right there and I put it, I'm going to put this into Spanish. I'm thinking this is an exponential form, 6 to this power. So the power is going to be down here. So this is the power, log of 13 where the base is 6. And over here I've got to write the word log, and then this is the base I'm going to use, 6. and then this y goes in the leftover spot. Well, it looks to me then that 13, doggone it, I keep meaning to hit the highlighter. 13 has got to equal y. Let me undo that. So 13 has got to equal my answer in order for this statement to be true. So 6 raised to the log of 13, where the base is 6, that answer will always be this little number right there. It's another property of logarithms that I don't really address much in our class. I think I'll stop, and we'll do a little bit more in the next piece of going from Spanish to English and English to Spanish. Here we were just trying to get used to the fact that a logarithm is an exponent. And so all these, what power was I raising 9 to get 9? Or, you know, way back here, 3. What power was I raising 3 to in order to get 81?